Picture yourself as a teenager, trying to imagine one impossible thing, chasing a beam of light, racing faster and faster alongside it until the light seems to hang there, frozen, right beside you. That's the daydream a young Einstein couldn't let go of. Chasing it down rebuilt space and time themselves, and today it quietly keeps the GPS in your pocket honest. Follow the beam, and ordinary ideas about time start to bend. It begins with something that feels completely obvious: motion. Ride a train gliding at a smooth, steady speed and pour a glass of water. It falls straight down, exactly as it would at home. Close the blinds, and there is no experiment you could do inside to tell whether you're moving at all. That's because there is no such thing as absolute rest. The traveler on the platform says you are rushing past. You say the platform is the thing rushing past you, and both of you are completely right. Motion only ever means motion relative to something else. Every steady point of view is just as valid as any other, and none of them is the one true, motionless center of the universe. But if everything is relative, is anything the same for everyone? It turns out one thing is. Measure the speed of light, and no matter how fast you move toward the beam or away from it, you always get the same answer, about 300,000 kilometers every second. Chase it as hard as you like, and it still races off from you at full speed. For that to be true, something has to give, and what gives is time itself. A clock racing past you ticks more slowly than your own. It isn't a trick of the eye. Fast-moving particles really do last longer, and the atomic clocks on GPS satellites have to be corrected for it every single day. Space bends to match. A fast-moving object is measured shorter along its direction of travel than it is at rest. Time stretches out, length squeezes in, and the closer you push toward the speed of light, the stronger both effects grow. Push that same logic a little further, and it reaches all the way into what things are made of. Follow the equations, and mass and energy turn out to be two names for one thing, bound together by E equals mc². Because c, the speed of light, is such an enormous number, even a tiny scrap of mass holds a staggering amount of energy. It's why the sun shines, turning a little of its mass into sunlight every second. And it sets a cosmic speed limit. Nothing with mass can ever reach the speed of light, because getting there would take infinite energy. From a child chasing a beam of light to E equals mc², one stubborn demand, that light look the same to everyone, reshapes space, time, and matter. Time bends, lengths shrink, mass is energy, and the universe keeps perfect time all the way down to the satellites overhead.